We're on page 371, number 11, and it looks like a pretty easy problem. Using the elimination method, all we have to do is add things together, right? Pretty straightforward. Jake?
Don't you have to multiply by -1?
Why? You don't really need to because these are already opposites.
Then why just cancel out?
Yes, exactly. It will. So go ahead. Add them together.
X equals 3.
We get 4x and minus 4x equals what, Will?
0.
0. So you put 0. Cancel. This cancels. You get 0. So 0 plus 0 equals 7 plus 7. 14. You get 0 equals 14. Is that true or false? It's false. It's false. Put 0 equals 14 false. Put 0 equals 14. And now just put false. Now, if it's false, what do we say in terms of solutions? You have to get the right lingo here. What kind of solution are we going to have for this problem? No solution. No solution. That's what it is. Okay?
Try my answer.
Just cancel.
In other words, when you get a question, that comes out with an absurd equation, in other words, something that is not true, obviously not true because 0 does not equal 14, the answer is there's no solution. And what does that look like on a graph? Does anybody have any idea? Anybody have any idea what that might look like on a graph? Well, what does it mean to have a solution?
To have an X and Y.
To have an X and a Y. In other words, to find a point where the two lines what? Where they cross, where they meet. Well, in this case, are they going to meet anywhere?
It's just going to be it's going to be a straight line.
Well, I know, but in what situation where we're going to have there will be lines, but they don't meet?
Parallel lines.
Parallel lines. Good job, Chase. See, this is going to be minus 5y equals minus 4x plus 7. So that's y equals 4/5 x minus 7 over 5. And the other line is going to be 5y equals 4x plus 7. And y equals 4/5 x plus 7 over 5. So they both have the same slope. This one here and that one there have the same slope, which means they're parallel, but one line is going through negative 7 over 5. That's going to be right about there, and it's going to be positively sloped, so something like that. This is an approximation. And the other line is going to go through 7 over 5, which is right about there, and it's going to have parallel action there. They're never going to touch. Parallel lines, okay? And no solution because the lines do not cross. Please write this down. Do this, please, as well. Everything I write on the board, you should write, okay? Lines don't touch or cross. No solution. Okay, write that down, please. Very important, including this. Okay? See how quickly I did that? You should be the same. I went ahead and converted that into y equals mx plus b in an instant. And then I know where the y-intercept is. I know what the slope is. And it's approximate, sure, but it's close enough. And I know they're parallel. I draw a quick sketch. I know there's no solution because the lines never touch. Bang, 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 bang. Real straightforward. That's your chapter 7. That's your chapter 3. It's all there. And it should go real quickly for you. If you watch these videos, then you should just practice it. Practice it over and over until you can do it like we do it in class. We're on number 12 on page 371. And this question is very similar to number 11, but it is different, and here's why. 2x plus 3y equals 4 and minus 2x minus 3y equals 4. What happens is that they cancel out when we add them, because 2x and negative 2x are opposites, 3y and negative 3y are opposites, and 4 and negative 4 are opposites. So you end up with 0 equals 0, which is always true. Now, what does that look like on a graph? A graph, when we go ahead and figure out what y equals mx and b is, we take 3y equals negative 2x plus 4, we get y equals, again, we're going to get the same thing, negative 2/3 x plus 4 over 3. When we figure that out, we divide by 3 on both sides. On this equation, we add 2x. We get negative 3y equals 2x minus 4. We divide by negative 3, and we get negative 2/3 x plus 4 over 3, which is exactly the same thing as this one. But what does that mean on a graph? It means they're the same line. When we graph it, it's actually going to be the same line. As you can see here, these two things, well, there's a black line and a green line, and they're written right on top of one another. It's the same line. It's always true. And what we say is infinitely many solutions. Why do we say infinitely many solutions? What does that mean? Well, what is a solution again? When two lines what?
Meet.
When they cross. Well, how many times do these two lines cross?
As many times as you can.
As many times as you can. Infinitely many times. They're always crossing. They're built that way. They're right on top of each other, and they're always touching. There's a solution every single point of the way. Everywhere along the way, there's a solution. You can't separate them. So that's why it's called infinitely many solutions. Does everybody know what the word infinite means?
Yes.
Yeah. What does it mean?
Keeps going on forever.
On and on forever. Infinity is this symbol, okay? All right? Sort of like the god of math. You know what I mean? You can't figure it out.
It's a sideways 8.
Sideways 8, yeah. There you go. Any other questions? Those two special examples are very important. You've got, to recap, in number 11, we had a false solution. There was no solution because the lines didn't cross. In other words, we had parallel lines. And in this one, we had both lines on top of each other, creating a situation where they always cross, infinitely many solutions. So to recap, there's three possibilities in terms of our answers. One is that there are infinitely many solutions. We get an equation that's always true. Second one is that there are no solutions. We get something that's false here, like 5 equals 10 or 5 equals 0. And those are parallel lines. And the last one is when lines cross, the most common, we get 1 point as our solution.